Hello, let's look at recursion in Rust, and I'm going to base it on an example from a book called Think Like a Programmer. The code that is written in is C++, but we're going to convert it to Rust. The method is to solve the problem iteratively first using the for loop. You reduce the size of the for loop by 1, solve the single case at the end, and then the author, Anton Sprawl, calls it the dispatcher function. Then you can remove the loop, get rid of the for loop. And basically, you make a recursive function, which you call the function itself, and then you add back on the dispatcher. This will make more sense in a second. I wanted to do this in Rust instead of the C++ example, just check that I could do it in Rust and just share it with any Rust users. So this is the example that uses iteration. And what it's doing is it's comparing two fictitious temperature sensor measurements. So you've got an array of 3, 3, 5, 7, 9, 12, 3, 5, 8, 10, 12, and the aim is to sum the differences. So you've got a difference of 1 between 7 and 8, and you've got a difference of 1 between 9 and 10, so the answer should be, 2. When you capture the results, we'll print them at the end as the counter. The counter increments itself as it iterates through the elements, and we use absolute. So you use stud num. Okay, so that is quite straightforward. That is how to do it with a for loop, but we're interested in recursion. So let's get on with that and look at the code. If you like this video, please subscribe, all that. Okay, so this is the part which looks familiar. We've got the array, but we're doing the size -1 here. And then array 2, size -1. So, and then the absolute. So what that's doing is it's comparing the last element in each of the arrays. And that's what we call the last element diff. So we keep that separate because when the stack unwinds, we add that on. The function we write will be called diff sum. So we're going to sum the differences. And we're going to pass in array 1, array 2. We'll borrow those. We'll pass references even. We'll pass in the size as a usize. And we'll return an i32. So first we need to check if the size equals 0, because that'll be our base case. So recursion always has a base case. That's when the stack starts to unwind, and then you start returning values from your function. Down here, we will call diffSum within the diffSum function. And as above, we'll pass in A1, we'll pass in A2. But this time we pass in size -1. Notice up here we passed in size. This takes a bit of getting your head around, but basically we reduce what we pass in to the inner function or the recursive function. We reduce it by 1 because that allows us to keep counting down until we get to 0, and then that allows us to to start returning values. Okay, so that's the function. Then we just need to use it. So res result equals diffSum, and then we pass in reference to array 1, reference to array 2, and then we pass in size. Size here we've set to 5. So that's a length of 5. Obviously the indexing goes 0, 1, 2, 3, 4. Then at the end we'll print the result. So if we run this, get the answer of 2. So it looks like a lot of code just to get the number 2 at the end, but let's go crazy and change this to I don't know, -3. See what we get then. So I'm thinking that'll be a difference of 1, and that'll be a difference of 8, so we should get 9. 10 even. Sorry, that was 8. Oh yeah, 5 and 3, that's the difference of 8. 5 to minus 3. We've got a difference of 1 there, haven't we? 7 and 8 is a difference of 1, and 9 and 10 is a difference of 1. So that's where we get our answer 10 from. I actually wrote this in Python first, and I was able to debug it in VScode just to see the stack unwinding. Probably I need to try and do something similar with Rust, because I don't always want to be writing recursive functions in Python to trial them before I implement them in Rust. But yeah, that's kind of the overall concept, is you take the end bit, you solve the last bit, or you break the problem down to the smallest part. So take the last part of the problem and you create that. So this is the line which is the overall idea or the overall concept that was being explained in the Think Like a Programmer book. You break the problem down to the smallest piece. Effectively, that's the last element difference, which is the bit that gets added back here. So if you can learn this method, understand it, write it in Python. I've done a video on my Python 360 channel where I cover it. And there's a link in there to pythontutor.com where you can actually see the debugging, and it gives you a visualization of it. If anybody's got any ideas on how to actually visualize this in Rust or debug it successfully visually in Rust, I'd be interested to hear. But what I wanted to do really was capture the concept which was in the Think Like a Programmer book and just test it out in Rust. I didn't want to code this live whilst talking and doing the video, but I did this earlier and I'd already written the Python version. And the Python version, maybe I studied the book for maybe half an hour, and then the Python example maybe took me 10-15 minutes. And to actually convert the Python example to Rust was actually, I don't think I even used ChatGPT. I just I converted it from Python to Rust and it took maybe 10 minutes. So yeah, by all means, if you find it easier to prototype a recursive function in Python, that's probably a good way to do it. So there we go. Thanks for watching, and yeah, have a go. Try it out. Try it out. Try it out in Python. Try it out in Rust. See what happens. It's one of those things that you do really have to experiment with, because just one one false move and you'll get some very strange results. So the other thing to remember is actually the return value. So make sure you understand what you need to be returning when you get down to the base case. Sometimes you'll need to return 1. Sometimes you'll need to return 0. It depends on exactly what the problem is and what the problem involves. But if it's a word, for instance, you might want to say if length of word equals speech marks or whatever. So just bear in mind this is the base case, this bit here. So you always have a base case, you have a recursive case, and you always need a way to travel or to work down from the recursive case down to the base case before you can then start returning some values with your function. So your function here, it will keep working down until it gets to 0. Once it gets to 0, then it will start returning values. And then you'll be adding the values. Whatever this value is, you'll be adding it to the last element, last LE diff. If this seems overcomplicated, then it's always worth just checking probably the best example is not the Fibonacci one. I would recommend maybe the factorial example, where you have, for instance, the factorial of 3 is the factorial of 2 plus 3. The factorial of 5, sorry, the factorial of 3 is the factorial of 2, times 3, and so on. I suspect you know where I'm going with that. So yeah, just study the factorial. Once you've kind of got the gist of the factorial, you always have your end, the last part of the problem, which is broken down, and then you just add that to what the recursive function keeps returning. So yeah, thanks for watching. I'll be back soon.